All right. Today we're looking at one of the best catches in the Super Bowl, dealing with Matt Ryan throwing the ball to Julio Jones. And now here we're breaking down the problem and the equation, factoring in Matt Ryan's height in terms of meters and 1.84 meters, the speed of the ball in which he threw it, and the angle, which is 25 degrees, and the height at which Julio caught the ball. And so these are the givens. And now the goal now is to find y top, which is the max height of the ball's trajectory. And now here, by using this equation, v equals v naught sine alpha minus gt, and using this formula and breaking it down even further, y top minus h1 equals v naught sine squared alpha divided by 2 times g. And breaking it down even into more simpler terms, which is y top minus h1 equals v naught sine alpha t minus half gt squared.
Action. Okay, so next you're going to use these three equations to find the maximum height. And to start off with, to find t1, you do the v naught over g times sine theta, which is 20 meters per second over 9.8 meters per second squared times sine of 25 degrees, which is going to give you 0.86249. So then you plug that in to this equation to find y1, which is 1/2 9.8 meters per second squared times this number 0.86249 squared, which is going to give you 3.6451. Then you're going to plug this in to the maximum height equation and do y1, which is this number 3.6451 meters plus 1.84 meters, which will give you 5.4850 meters. And that is your max height.
Okay, for part 2, we're solving for how long it takes the ball to reach Julio's hands. So for this part, we need T2, which is the time from the highest point to Julio's hands. And you would set T2 equal to 2 times y top minus h2 over g, all squared to the power of 1/2. That could also be broken down into v naught squared times sine squared alpha over g squared minus 2 times h2 minus h1 over g, all to the 1/2 power. Then you plug in the numbers. You have 20 meters per second. 20 meters per second times sine squared theta, and theta would be 25 degrees over 9.8 meters per second squared, so basically 9.8 squared, minus 2 times 2.13 meters minus 1.84 meters over 9.8 meters per second squared, all to the power of 1/2. And for your answer, you would end up with 0.8275 seconds. After you do that, you have to get the total time of the ball's trajectory. And to do that, you would set t equal to t1 plus t2. So you would plug those numbers in. So you would have 0.86249 seconds plus 0.8275 seconds, and you would get 1.690 seconds.
And so now we went through part 1, part 2. Now this is part 3. Part 3, we want to know what is the horizontal length of the pass when Matt Ryan threw it to Julio Jones for him to catch the pass. So we know the horizontal length of the pass. The equation, the formula is the length equals the initial velocity, also known as v naught, times the cosine of alpha times t, which is time. So now what we do is just plug in our data. Okay, so our initial velocity is 20 meters per second times the cosine of alpha, which is 25 degrees, okay, times the time, which is 1.690 seconds. And when we multiply these numbers, our horizontal length of the pass is 30.63 meters.